For this recording, I'm going to find the volume generated by revolving the area bounded by y equal to 4 minus x squared, x equal to 0, and y equal to 0 about y-axis using the method of cylindrical shells. First, what is the area bounded by y equal to 4 minus x squared, x equal to 0, and y equal to 0? If you are not sure, you can form a table of x and y. So when x equal to minus 2, y is y. Then you find out you get y equals 0, y equal to 4 minus x squared. When x equal to minus 1, y is y. Then you find that y is equal to 3. When x equal to 0, y is y. You find that y is equal to 4. When x equal to 1, y equal to 4 minus x squared will be 3. When x equal to 2, y equal to 4 minus x squared will be 0. And so, this is how the graph of y equal to 4 minus x squared look like. You have a xy axis. So 1, 2, 0, minus 1, minus 2, and 1, 2, 3, 4. So you have minus 2, x equal to minus 2, y 0, x equal to minus 1, y 3, x equal to 0, y 4, and you get all this point. So you get a curve y equal to 4 minus x squared. And this is a parabola. And then the graph of x equal to 0. So x equal to 0 is the y-axis, and the curve y equal to 0 is the x-axis. So the area we are interested in is this portion of the area, and this portion of area is going to revolve about the y-axis. And we are interested to find the volume of this by using the cylindrical shell method. So what is the cylindrical shell method? This is what happened. You have a area region from A to B under the graph of y equal to f(x), and you slide the region parallel to the axis of rotation. So you slide the region parallel to the axis of rotation like this, parallel to the axis of rotation. So from this slide, for example, you are going to get many thin shells, and you stack up the volume of these shells and you sum them up and find the volume of the solid generated, and the volume is given by the formula integration from a to b 2 pi x times f of x dx. Now I'm going to solve this problem. Instead of using the formula directly, I show you the reasoning. Okay, let me redraw the area I'm interested in. This is the area I'm interested in. Let me select them and copy. So the area I'm interested in will be here. Slide this vertically at the point x here, and this slide will be rotated about the y-axis, and it will generate a very thin shell when you rotate about the y-axis. So you get a thin shell like this come up. And what we're going to do is find out the volume of this thin shell. And how to find the volume of this thin shell? This is a shell, the center is hollow. So what I'm going to do is I'm going to cut the shell on one side and open it and roll. So when I cut it open and roll out, where this will be the thickness of the shell. Now let's try to find the volume of this little thin shell. I call this volume delta V. How to find the volume? So I need the thickness. The thickness is this delta X here, which is the thickness of the shell. I also need the height of the cylinder. So the height is the same as this height here. This is my Y. So the height is Y. I also need the length. So the length in this case is equal to 2 pi x. It's because the distance of the shell to the y-axis is x. So rotate this thing. So when rotate the shell about the y-axis, you get a circle. And so when you cut the circle, you're going to get a circumference of circle out, which is 2 pi x. So the volume of this thin shell is 2 pi x times y times delta x. So in order to find the volume of the solid generated, you sum up all the little thin shell. Looks like something like this in a very roughly speaking. So and you let the thickness of the shell goes to 0, and so V is equal to integration of 2 pi x y dx now, where my value of x go from x equals 0 to 2 in the yellow region. The volume I've generated is integration of 2 pi x y dx. Now y is equal to 4 minus x squared. So let's continue. So V equal to x from 0 to 2, 2 pi x y dx, and y is equal to 4 minus x squared. So throughout 2 pi, I have 4x minus x cubed. After I multiply the x and 4 minus x squared, so integrate 4x, I get 4x squared over 2. Integrate x cubed, I get x power 4 over 4, and limit from x equals 0 to 2. So when x equal to 2, I get first number, 4 times 4 is 16 over 2 minus 16 over 4. And when x equals 0, I have all the numbers 0. So this will give me 2 pi, 8 minus 4 is 4. So answer is 8 pi. The volume of the solid generated is 8 pi. And this method is called the cylindrical shell method. And that is the end of this recording.